Hey ladies and gentlemen, welcome to the first video of 3 for the final section of Chapter 1 in your McGraw-Hill geometry textbook. That is Section 6 of Chapter 1 on two-dimensional figures. This will consist of 3 videos. The first video will be vocabulary, the second video will be vocabulary, and the third video will cover area and perimeter. None of this information should be 100% new to anyone taking this course, but it has been a while since you've seen it, so if you don't remember it, that's understandable. So here we go, last set of videos for Chapter 1. Starts with a vocabulary word, polygon. A polygon is a simple, meaning what that means is that every vertex is only 2 sides connecting. We'll discuss that a little bit more here in a minute. A simple, closed, two-dimensional figure made up entirely of line segments. So we're saying no curved sides. So down below here we have some examples of some polygons and some non-polygons. I tried to make some that were a little bit more complicated and some that were more like what you expect to see. So on the left here you see a triangle. It's actually an equilateral triangle. A quadrilateral or square. A decagon, that is a 5-pointed star. It's got 10 sides. And another decagon that I believe is supposed to represent a factory and exists in this program for econ purposes. But anyway, over on the left here you see some examples, and this is probably the part that's more important for us at this point, of things that are not polygons. So what we're going to do is we're going to label why each of these is not a polygon. First shape should be obvious. It has one side that is entirely a curve. You can't have curves. It's also the reason why this is not a polygon, because it has a curved side. Can't have curves. You have to have line segments only. The top right, here's an example of what I mean when I say that this is not simple. There are a total of 4 sides coming together at this vertex right here. There can only be 2. So that would be an example of that shape folding over on itself, which makes it not simple. And then finally, this bottom one is not because it is not closed. So it should be relatively easy to tell the difference between polygons and not polygons. Now, naming polygons, there are all kinds of polygons, and we name them based on their number of sides. So what we're going to do is we're going to create a little reference item here. All of these names become vocabulary words immediately that you are expected to know. If a polygon has 3 sides, you've done an extensive amount of work with 3-sided polygons, like these pictures over here. You know them as triangles. 4-sided polygons, you've seen all of these shapes before in grade school. They each have their own name. In fact, there's an entire chapter in this book dedicated to 4-sided polygons. Those are known as the quadrilaterals. And by the way, if you name a specific type of quadrilateral, you will be wrong. Quadrilateral meaning 4 lines, 4 sides. 5-sided polygons, there's a couple examples over here of various 5-sided polygons. Those are known as pentagons. Penta meaning 5. 6-sided are hexagons. 7-sided are heptagons. 8-sided, big example we see out in the world. Stop signs are octagons. Some of you probably know the word octagon from other places. It's an 8-sided polygon. 9-sided is known as a nonagon. 10-sided are known as decagons. And the only other one that we have an official name for is a 12-sided polygon, which is known as a dodecagon. Now, I didn't provide pictures for the other ones because, to be honest, it's not really that important that you see an overall picture. What you do is you count up the number of sides, and then you name the polygon based on how many sides it has. So, for instance, on this pentagon right here, you would go through and you'd go 1, 2, 3, 4, 5 sides. That's a pentagon. 1, 2, 3, 4, 5. See what I'm saying? Okay. Now that brings up an interesting question. What do you do if the number of sides is not listed in the chart? This thing right here in front of you is a polygon. Every single one of its sides is a line segment. There's no vertex where more than 2 sides come together, and it is closed. So what we would do is we would count the sides. We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24 sides. Now that's not in the chart. Well, it's actually much easier than it sounds. Okay, if a polygon is not listed in our chart, we name it an n-gon. What do you mean n-gon, Mr. Wills? Well, what I mean when I say an n-gon, this thing has 24 sides. So n is 24. So this would be a 24-gon. Okay? We just list the number of sides as a number and then put dash gon on the end of it. So 11 sides would be an 11-gon. 45 sides would be a 45-gon. Okay? If it's not listed with a specific name, we just attach a dash gon to the number of sides. It's that simple. That does it for the first video for section 6.